All right, Unit 7, Lesson 1, Investigation 1, Trig Functions. Yesterday we introduced ourselves to these with that worksheet we did. Remember from yesterday we had a right triangle with some sides labeled. Right? We'll start there today. Anybody remember what theta is?
Yeah, it's that circle and that thing.
Circle line through it, good. Is it, what kind of letter is it?
What?
Matt? It's a Greek letter, good. What does it represent? Angle measure, good. Theta is a Greek letter and it represents angle measure. It's our variable for angle measure. Now yesterday, theta was down here, right?
Yeah.
Today theta is up there. Does it matter where I put theta? No. It just represents an angle that we're trying to find. Now, we're going to talk about trig functions. Yesterday when we did the little activity, we learned that these trig functions we're going to learn about depend on ratios of side lengths, right? We worked with ratios of sides yesterday, right? So one thing we need to know about the sides of a triangle before we can figure out these trig functions is which side is opposite, adjacent, and which side is hypotenuse. Okay? Now when I'm talking about opposite and adjacent, that's relative to our theta. So looking at theta, theta's right here. Which side is opposite theta?
C. A. B.
A. Remember, opposite means across from. Okay? Now, when we're talking about adjacent, I actually like to do hypotenuse first. Okay? Because adjacent is the side next to the angle. So that's not the hypotenuse. Right? Matt, you're on the right track there. Okay? So, Matt, which one's our hypotenuse?
C.
C. Remember, our hypotenuse is the one across from the right angle. Right? So our hypotenuse is C. And then adjacent is the side next to the angle that's not the hypotenuse. Right? So here's my angle. Which side's next to it? B. C's also next to it. Right? But it's the hypotenuse. So my adjacent is B. Okay? Any questions about how I name those sides? Or how I picked them out as opposite, adjacent, and hypotenuse? Okay, this right here, figure out which side's opposite, which side's adjacent, which side's hypotenuse, that's the toughest part. Okay, I'm not going to lie, that is the toughest part. If you can identify the opposite side, the adjacent side, and the hypotenuse, then the sine, cosine, tangent stuff is going to be easy. Right? So if you can do that, opposite, adjacent, hypotenuse, then you can do the sine, cosine, tangent stuff. All right, yesterday with trig functions, we learned that trig functions will give us ratios of side lengths for right triangles, right? Because yesterday with our activity, all we dealt with was right triangles, right? And we wrote down the ratios of side lengths. We did the x over the y or the y over the r, all that stuff, right? Right? Now those x, y's, and r's, what did they stand for? They were the sides of the triangle, right? So they're the opposite, adjacent, and hypotenuse for the triangle, right? So what we did yesterday, we were making these trig ratios even though we didn't know it yet. Okay. All right, now, next thing we learned from yesterday was the only way to change the value of sine, cosine, and tangent is to change the angles. Okay? If I just make the triangle bigger, does that change the ratio? No. All right? All the sides will get bigger, but they'll all get bigger by about the same amount, which means that the ratios are going to stay the same. Okay? They'll all get bigger by the same factor, not the same amount, but the same factor, which means our ratios will stay the same. Okay? So the only way to change the value of sine, cosine, and tangent is to actually change the value of our angle, to change what the angle measures. Okay? All right. Our three trig functions are sine, cosine, and tangent. If you look on your calculator, you can find the shorthand for those words, all right, or the abbreviations, right? Does anybody know what the abbreviation for sine is? Sin, okay. It's spelled S-I-N, but it's not sin. Okay? It still stands for sine. All right? I know you guys are in the habit of calling it sin because you're just saying the word, right? But it's sine. I'll say sine. So when I say sine, and I call this sine, it's because it refers to the word sine. Right? Does that make sense? Okay. What abbreviation is cosine? Cos, right? C-O-S. So when I say cosine, that's my abbreviation, COS. Right? What's the abbreviation for tangent? Tan. Okay. And they're all right in a nice row for you on your calculator, aren't they? Excuse me. Now, sine. Sine is a ratio between the side opposite our angle and the hypotenuse. So in order to find the sine of a function, or not sine of a function, in order to find the sine of an angle, we take the opposite side and divide by the hypotenuse. All right, does that make sense? Okay. So if I want to find the sine of angle theta, okay, here's angle theta, right? Which side is opposite theta? A, right? So where I have opposite, I write A. Which side's my hypotenuse in this triangle? C. So the sine of theta in this triangle, the ratio for sine of theta is A divided by C. Does that kind of make sense? Okay. All right. Now cosine theta is adjacent over hypotenuse. Okay? This is why it's important to be able to identify your opposite, adjacent, hypotenuse. Right? To find the ratio for cosine of theta, we use the side adjacent. Which one's adjacent? B. So we write B. Which one's hypotenuse? C. So B over C.
But is it going to tell us what to divide over?
What's the divide?
Like, it's going to tell us, like, adjacent hypotenuse, like you got there.
Adjacent hypotenuse, yep. Well, I'm not going to tell you. I'm going to say what's the cosine of the angle, and you need to know that cosine is adjacent over hypotenuse. Okay? Sine is always opposite over hypotenuse. Always. Okay? Cosine is always adjacent over hypotenuse. Okay? From that angle. Right? And tangent is always opposite over. Nope. We already did opposite over hypotenuse. Opposite over adjacent. Right? Tangent is always opposite over adjacent. Now, what's my opposite side again?
A.
A. What's my adjacent side?
B.
B. So this is always going to be A over B. Okay, now before we move on, all right, with sine, which of these is always going to be bigger? The opposite side or the hypotenuse?
Hypotenuse.
Hypotenuse. Hypotenuse is the biggest side of the triangle, right? Right? So our hypotenuse is always going to be bigger, right? So if I have a small number over a big number, this will always make a what?
Decimal.
Decimal, right? So sine is always less than 1. Okay? And it must be positive because side lengths are positive. Right? Now, is that true for cosine?
Yes.
Yeah, because cosine is a side over the hypotenuse. Hypotenuse is bigger, isn't it? Right? So a smaller number over a bigger number. So this will always be less than 1. Now for tangent, can we make that conclusion? No, because the opposite side could be bigger than the adjacent side, right? And the adjacent side could be bigger than the opposite side. So tangent will sometimes be bigger than 1, sometimes it will be less than 1. It may even be 1 in some cases. Okay, it might equal 1 sometimes, right? So tangent can be any number. Okay. So a good way to check yourselves when you're doing this work, if sine is less than 1, right? If we have a big number over, or sorry, a small number over a big number, then you probably did it right. If cosine is less than 1, okay, a little number over a big number, then you probably did it right. Okay. Tangent, there's no real check for that one. Okay, so basically, if your sine is bigger than 1, or if your cosine is bigger than 1, then you probably wrote the ratio incorrectly. Okay. Now today, all we're going to do is we're just going to write the ratios. We're not doing anything with angle measures yet. We're just going to write out the ratios. We're just going to do opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. All right, we're just going to get used to writing those ratios down, and then tomorrow or the next day we'll introduce angle measures. All right. Now, sine, cosine, and tangent. These ratios, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, those are things that you will need to memorize for the ACT. All right. So if you're planning on taking the ACT and you're planning on scoring well in the ACT, you need to be able to memorize those ratios. So we have a little acronym for helping you memorize those ratios. You may have heard this before. You may have seen an older sibling or cousin or upperclassman talking about this. The acronym is Sohcahtoa. Okay? Sohcahtoa. What do you think the S stands for? Sine, right? What about the C? Cosine. What about the T? Okay? And then the other letters help us remember what the ratio is. Okay? Sine is opposite over hypotenuse. I like to abbreviate opposite and hypotenuse because they're long words. And I might spell them wrong. Okay? Cosine is adjacent over hypotenuse. It is. And tangent is opposite, not opposite adjacent, opposite over adjacent. Now I like to write it vertically like this because then opposite's above hypotenuse, right? Helps remember opposites over hypotenuse. Okay? Adjacent over hypotenuse. Opposites over adjacent. So I like to write it down the page like that. Okay? Because it just helps remember what the equations are. All right? You can also write it normally, so just like Sohcahtoa, like left to right, like you normally do. All right? But when we take our unit test over this, when we take our formative quizzes, I expect to see this written in the margin. Okay? Because this will help you figure out the ratios. All right? So try to memorize Sohcahtoa. All right? I'll write those letters over on the board over there by Rock, so that way at least the letters will be there when we're doing our work in this, so that we can remember Sohcahtoa. All right? My wife, who didn't study math in college, took one math class her freshman year. She still remembers Sohcahtoa. All right? I was drawing the triangles up this weekend. She goes, "Are you doing Sohcahtoa?" She got all excited about it. She remembered all the stuff you can fill in. Okay? So this is something you need to memorize. Okay? You can tell your kids about it someday. All right? When your kids are using like iPads and all that good stuff.
Yeah, when our kids are doing this stuff in like first grade.
Probably on their 3D iPads that throw polygons for them. Right? They'll actually throw the fruit up and they'll actually cut it with their hand. You know?
That'd be so cool.
It would be cool. Apple probably has it already made. They're just waiting to release it. All right. Any questions about these functions? Any questions? All right. Let's try them out by saying, okay, that sounds simple enough. Let's see it in action. Okay. Here I have 3 examples. All right. Example 1, 2, and 3. We'll do example 1 together, and I'll let you guys try 2 and 3 on your own. Okay. Here's my angle theta, right? Right? Okay. Different location than the one I had at the beginning of class. Okay? So keep that in mind as we go through it. I know it's not to scale. The 5 and the 12 look about the same length. I understand that. Okay. Just use the numbers that I wrote. So cosine theta. Cosine is adjacent over hypotenuse, right? Here's my theta. Which one's my hypotenuse?
13.
13. So 13 is on bottom. Which one's adjacent? 12. Will this be less than 1? Yeah. So I probably did it right. Sine. Opposite over hypotenuse, right? Which one's my hypotenuse?
13.
13. Which one's opposite theta? 5. It's 5 over 13. And then tangent, last one. Opposite over adjacent. Here's theta. Which one's opposite? 5. Which one's adjacent? 12. Does that make sense? You guys think you can do that? Okay. This one is a 3, 4, 5 triangle, right? And this one is, oops, erase the 5.65. 5.65, 4, and 4. Okay. So 4, 4, 5.65. So try sine, cosine, and tangent for those 2 triangles. Right? Shouldn't take too awful long. What? I think 3 minutes is enough time.
5.
5 minutes?
Yeah.
We'll split the difference. We'll go for it. Go for it. I can't do half minutes. You know that.
You could have said after it goes far, you should 1, 2, 3.
I will.
Mr. Dressing. You do better yourself.
Hypotenuse? The hypotenuse is always opposite the right angle. Okay. And with these ones, the hypotenuse is opposite the right angle, and it's the biggest side.
What's adjacent? Next to?
Adjacent is next to, but not the hypotenuse. And opposite is across from.
You wrote that down. Not even Oh, no, I was joking. And then I was missing you mean that have a late night? You know.
John, did you do the examples?
Yeah, you did.
John Smith,
What?
did you do the examples?
Yeah.
Yeah? All done? All right, let's try these out. So for this one, here's theta, right? Cosine is adjacent over hypotenuse. So what's adjacent? 3. What's hypotenuse? 5. Good. Sine is opposite over hypotenuse, right? So 4 over 5. And tangent is opposite over adjacent, so opposite is 4. Adjacent is 3. Okay? So, less than 1, right? Right, guys? Less than 1? Less than 1? More than 1. Okay? Tangent can be more than 1. That's okay. Alright? But this one, sine is opposite over hypotenuse, so 4 over 5.65. Cosine, adjacent over hypotenuse, so 4 over 5.65. Okay. Tangent, opposite over adjacent, 4 over 4. Right? So, less than 1? Less than 1?
1.
1. Okay. So, tangents can be 1, more than 1, or less than 1. Sine, cosine should always be less than 1. Are there any questions? Okay, like I said earlier, if you can pick out opposite, adjacent, and hypotenuse, then this will be easy. All right?